grade 10s, what I've done is I've got my values from my experiment, and you might notice that the readings here are just a little bit higher than what you might have got, and a possible reason for that is that these cells are brand new. I've only used them once. The ones around the classroom here that you've been using have been used a lot. They've been used over and over again. And a way of knowing how old or how tired your cells are is these values would all be much lower. So for one cell, you might have a much lower value. For two cells, even still a lower value. And you might find that your values don't go up in the same amounts as well. And that could be that your cells aren't all at the same stage in their lives. They haven't all got the same amount of energy they are giving to your circuits. But let's have a look at the relationship. That's the next thing we have to do. From our values, we've got 1 cell, 2 cells, and 3 cells. From our values, we need to describe the relationship between the current in the circuit and the potential difference across that light bulb. So there's a certain amount of current flowing through the light bulb, which we get from our ammeter, and there's a potential difference across the light bulb, which we get from our voltmeter. So this is measured in amps, all these top values. These bottom values are measured in volts. So what's the relationship between the current and the potential difference? Let's have a look. As my current increases, what do you notice about the potential difference values? It also increases. So the way we would describe that relationship is we would say the relationship between current and potential difference is that current is directly proportional. The current through the circuit is directly proportional to the potential difference across that light bulb. So the current through the light bulb is directly proportional to the potential difference across it. Directly proportional means as one increases, the other increases. So I'm going to write that here. As your current increases, V also increases. That's basically what it means. Another way you could write that is you could say potential difference is directly proportional to current. Current is directly proportional to potential difference. They are directly proportional to each other. So as your current increases, your potential difference also increases. And what we're going to do with these values is we are now going to plot them on a graph. So on the graph, you've been given the graph paper at the bottom there of your piece of paper, your worksheet, and it says draw a neat line graph in the space provided with potential difference on the y-axis up the side, potential difference of your voltage, the voltmeter readings up the y-axis, and your current along the bottom axis. And you need to choose the correct scale. If you look at my values over here, it's 0.2, 0.3-ish, 0.37. So you need to choose a scale for your current, and you need to choose a scale up the side for your potential difference. I'm not going to tell you what to do. I'd like to see what you do with it first, and then I will show you what is the correct way of graphing this. So on your piece of paper there, you can put your heading, which would be graph showing the relationship between something and something. Graph showing the relationship between, what are the two things that we've tested? Connected current and potential difference. You don't have to put them in that order, you can put them the other way around, potential difference and current. But those are the two things that we have tested, the two quantities that we've tested in our circuit. So it's a graph showing the relationship between current and potential difference, or potential difference and current in a given circuit. Current must be on the x-axis and potential difference on the y-axis. So you have another, let me give you 10 minutes to draw this graph, and I think I might have a ruler. I do. It's a bit of a short one. If you would like to borrow this ruler, we can circulate it around the class just to draw on the line, but you can plot the points up to now. Okay, so plot the points first, and then we'll circulate the ruler.